Evaluating trigonometric limits using special limits. Alright, so we're going to take a look at our first example here. Here, we want to evaluate the limit as x approaches 0 of sine of x over x. So as always, the first thing we're going to try is we're going to try direct substitution. So we'll have the limit as x approaches 0 of sine of x over x is equal to sine of 0 over 0. And if we keep evaluating, we know that sine of 0 is going to be 0. And then we have a 0 on the bottom, so that stays alone. Alright, great. So we know that 0 over 0 means that we have to factor and cancel. So we just need to factor the sine of x and x. So this is where we run into a problem with this whole factor and cancel thing. Because we can't factor sine of x, and we can't really factor x, so therefore there's nothing to cancel out. Some students like to make up some math and like, oh, x on the top, x on the bottom, they cancel out. Which would be great if they did, but sadly they don't. This x in the top is inside of the sine function, so it's protected by the sine and therefore can't be canceled out. So, unfortunately, when it comes to trig functions, factoring and canceling in this situation will not work. So, we need to learn a whole new set of identities for trig functions. So these are special identities for limits of trig functions. And our first identity is if we have the limit as x approaches 0 of sine of some a value times x over x. Now, later on in the semester, we will go in and we will prove why the answer is the answer, but for now, you just need to take my word that the limit as x approaches 0 of sine of ax over x is just going to be a. It's just going to be the coefficient of our x that's inside of the sine function. Now, one thing to point out, this particular limit equals a only when x approaches 0. If x approached any other number, this limit would not be true. Alright, so then moving on from there, we're going to look at limits in the form of the limit as x approaches 0 of x over sine of ax. So this is similar to the first identity, except it's the reciprocal of it. And just like you'd imagine, if the limit is the reciprocal, the other side is also going to be the reciprocal. So this particular limit equals 1 over a, or 1 over the coefficient of x inside of the sine function. And if you notice, this limit is also only true as x approaches 0. Moving on, our next form is when we have the limit as x approaches 0 of sine of ax over sine of bx. And again, in later lessons in this course, we will actually talk about how we get this particular answer as well, but for now, I just have to take my word that the limit as x approaches 0 of sine of ax over sine of bx is just a over b. It's the coefficient of the x inside of the sine in the numerator over the coefficient of x inside the sine in the denominator. And just like the first three, this is only true when we have x approaching 0. So these are the three identities for the sine functions. What about cosine? Well, if we have a limit as x approaches 0 of cosine of ax minus 1 all over ax, that's going to give us an answer of 0. Now, a couple things to point out here. Just like all of our other identities for limits of trig functions, this limit also approaches 0. But there's one other important factor here, is that this only equals 0 if the function inside of cosine matches the function in the denominator. If these two functions, or excuse me, if these two expressions don't match, this identity is not true. So again, two conditions for this limit. One, x has to approach 0, and the expression inside of cosine has to match the denominator. Now we do have one more identity for cosine. It's really the same as this first one, it's just we are flipping things around. So in this particular limit, we have the limit as x approaches 0 again, but this time we have 1 minus cosine of ax all over ax. So again, the inside of the cosine has to match the denominator, and if that's true, this limit also equals 0. So a lot of these identities have to deal with the coefficient of the expression inside the trig function. And also the limit has to approach 0 for all of these to be true. Alright, so now that we have these identities, let's go back and try to evaluate that first limit. So we have the limit as x approaches 0 of sine of x over x. So now I'm going to write this one a little bit differently just so we can be a little bit more explicit. I'm going to rewrite this to be the limit as x approaches 0 of sine of 1x over x. And the reason I wrote it like that is because I want this to be in the form of the limit as x approaches 0 of sine of ax over x, which I know equals a. And in this particular limit, I can see that a is going to be 1, so therefore I can say that this limit is equal to 1. There you go. Nice and easy as long as you remember the identities. Next up, we have the limit as x approaches 0 of sine of 8x over x. So this particular limit is in the same form, the limit as x approaches 0 of sine of ax over x, and we know this is going to be a. So all we need to do here to evaluate the limit as x approaches 0 of sine of 8x over x is identify our a value, which we can see is 8. So therefore this limit is just going to equal 8. Next up, we have a limit as x approaches 0 of sine of 2x over 3x. Now, this kind of looks like the form we've been working with, the limit as x approaches 0 of sine of ax over x is going to equal a. And while the numerator does match because we do know that a is equal to 2, the problem is our denominator doesn't match. We have a 3 when we want the x by itself. So we're going to need to do a little bit of fancy algebra here to get rid of that 3. So I can rewrite this limit as being the limit as x approaches 0 of 1/3 times sine of 2x over x. So basically, I just pulled the 3 from the denominator out and made it its own fraction. And when I did that, this 1/3 acts like a coefficient. And based on our properties of limits, we know that we can factor coefficients out of the limit. So this is going to give us 1/3 times the limit as x approaches 0 of sine of 2x over x. And now we have the limit matching our identity, so we just have to identify the a value, which we said was 2. So that means we're going to have the 1/3 times, and the limit as x approaches 0 of sine of 2x over x is 2. And then we just have to simplify. 1/3 times 2 is 2/3. All right, next up, we have a new identity we're going to be using here. So we're going to evaluate the limit as x approaches 0 of 7 times sine of 3x over 5 times sine of 4x. So this looks like the form, or looks like the identity, the limit as x approaches 0 of sine of ax over sine of bx. And if we look at our limit, the limit does approach 0, so that's good. We do have an a and a b, so that's good. But the issue is this whole 7 and 5 in the front. So similar to the last equation, what we're going to do is we're going to try to make that 7 and a 5 a coefficient, and then try to factor it out of the limit. So to do that, we'll have the limit as x approaches 0, and this will be 7/5 times sine of 3x over sine of 4x. So now this 7/5 is essentially a coefficient, which means we can factor it out. So this is going to give us the limit. Oh, sorry, excuse me, got to start with that coefficient. This is going to give us the limit of 7/5 times the limit as x approaches 0 of sine of 3x over sine of 4x. And now we do match, which means all we have to do is identify our a value, which is 3, our b value, which is 4, and then substitute in for our identity. Which means we're going to get 7/5 times 3/4. And hopefully remember, when we multiply fractions, we multiply tops with tops, bottoms with bottoms, giving us a final answer of 21/20 as our limit. Next up, we want to evaluate the limit as x approaches 0 of cosine of x minus 1 over x plus 7. So this looks very similar to our limit as x approaches 0 of cosine of x minus 1 over x. And excuse me, I forgot my a value, so let's just back that up there. So it's going to be cosine of ax minus 1 over ax is equal to 0. Well, now we can see in the first part that the expression inside the cosine does match our denominator. So we are good there. However, we've got this pesky plus 7 tacked on the end here, which our identity doesn't have. So we have to somehow pull that plus 7 out of the limit. And fortunately, again, we know some limit properties, and we know that with addition, we can break this apart into two separate limits. So I'm going to have the limit as x approaches 0 of cosine of x minus 1 over x plus the limit as x approaches 0 of 7. And now we can apply our identity to the limit that matches it. So the limit as x approaches 0 of cosine of x minus 1 over x is going to be 0. And then we know the limit of a constant is just going to be that constant. So the limit of 7 is going to be 7, which means our solution will just be 7, because 0 plus 7 is 7. All right, next up, we're going to evaluate the limit as x approaches 0 of 3 minus 3 cosine of x over 7x. Now this one looks kind of a little bit similar to the identity, the limit as x approaches 0 of 1 minus cosine of ax over ax, and that would equal 0. Well, if we look, the limit does approach 0, so we're good in that category. Let's see. We have a number minus a cosine, so in that aspect, we're good. But the problem is that we don't have 3's in the identity. But both of our terms in the numerator happen to have a 3, so we can factor a 3 out. So we're going to end up with 3 times the quantity 1 minus cosine of x over 7x. The next thing we need to check for is we need to check that if the expression on the inside of cosine matches the denominator. And in this case, they do not match. The expression in the denominator has that extra 7. So we need to get rid of that 7, so we need to pull it out of the fraction. So I can solve both of my problems here by making this the limit as x approaches 0 of 3 over 7 times 1 minus cosine of x all over x. Because then that expression matches our identity, and we can just factor what is now the coefficient out of the limit, and we are golden. So we're going to have 3/7 times the limit as x approaches 0 of 1 minus cosine of x over x. And based on our identity, we know the limit as x approaches 0 of 1 minus cosine of x over x is 0, and 3/7 times 0 is 0. So there you go. There is our solution. Now our final example, we're going to look at the limit as x approaches 0 of 1 minus cosine of 5x all over 10x. So this one does seem to look close to the limit x approaches 0 of 1 minus cosine of ax over ax equals 0. However, our expression inside a cosine does not quite match the expression in the denominator. So we need to think, is there any way that we can turn 10x into 5x? And you better believe it, because I can rewrite this as the limit as x approaches 0 of 1 minus cosine of 5x all over 2 times 5x, because 2 times 5 is 10. And then I can use the trick that we've used earlier, where I can pull that 2 out of the denominator to give us the limit as x approaches 0 of 1/2 times 1 minus cosine of 5x over 5x. And then the 1/2 is essentially a coefficient, which means we can factor it out, leaving us with 1/2 times the limit as x approaches 0 of 1 minus cosine of 5x all over 5x. And that's going to leave us with 1/2 times. And since the limit now matches the identity, we know that that guy is going to be 0. And 1/2 times 0 is 0. And there you have it. So the important things to remember is, does x approach 0? Can you make what we have look like what we want? And with the cosine identity, make sure the inside of the cosine function matches the denominator.